Hello world. Today I'd like to talk about a C++ specific design pattern called CRTP, or the Curiously Recurring Template Pattern. The quick synopsis is that it is a technique you can use when you want to have polymorphic behavior in some classes, but you know what those classes are going to be at compile time, so you can thus get compile time polymorphism. Let's take a look as to how this works. Consider the curious base class. This is the basic element of CRTP. It is templated on the derived type. This allows us to, within this class, cast ourselves, or this pointer, to our derived type. That allows us some interesting mechanics. Consider further. Our derived class here, derived, inherits from curious base passing itself in. Notice that Derived has a member function foo. Though curious base does not have that member function foo, its member functions can cast themselves to the derived type and call foo on it. This means that we're not going through any sort of a virtual function call. Rather, at compile time, the compiler is going to set up the function call directly to our derived type's function. There is a limitation to note in C++, and it's an interesting part of the language to understand in its own right, and that is the difference between a complete and an incomplete type. When we create a class like derived here, derived is not considered what we call complete until we get to the semicolon, which means that we are passing into curious base an incomplete type. For a template taking an incomplete type, that gives it some limitations. If we had this type on derived, for instance, this alias we're calling type, curious base could not refer to that type inside the scope of the class outside of the member functions. Note that the compiler error here uses this phrase directly, invalid use of incomplete type struct derived. We can see though that the member functions themselves do not care. And just to prove this out, let's actually write a little bit of a main function to show this all fully compiled and running. Main function here, notice that we are calling to curious base of bar, is then going to call off to as derived to get foo. So this is what I mean by compile time polymorphism. The curious base is able to use functionality from the derived class without having to pay a runtime performance to go through virtuals or these similar. If you'd like to see a detailed usage of CRTP, you need look no further than Boost's operators library, where you can get a swath of additional operators defined for you, so long as you define some related versions, such as you define less than operator and it will give you greater than or equal to, less than or equal to, etc., etc. You define equivalence and it'll give you not equals and the like. And that is all done using CRTP. Thanks for watching. I hope you enjoyed the video. If anything was unclear or you would like to hear about another topic in the future, please let me know in the comments. And don't forget to subscribe if you'd like to hear more.